This week, discover how Matplotlib uses subplots to let you create multi-panel figures. Welcome to another MetPy Monday. Hi, I'm John Lehman, a software engineer at Unidata. On this week's MetPy Monday, we're going to talk about how to create multi-panel charts with Matplotlib. This is something very useful when you're trying to create, say, a 4-panel synoptic plot, or a multi-panel plot showing different satellite fields, or any kind of chart where you're going to have different variables that you want to show on completely different scales, maybe or maybe not sharing, say, an x-axis. So to start out with, we're going to go ahead and do our imports here. We're going to import NumPy, as we're going to need that to generate some random data to show. Going to import matplotlib.pyplot as PLT, and then we're going to use the matplotlib inline magic here. Okay, so first we're going to create some random data. So X is going to be an array, in this case going from 0 to 99. My y1 variable, I'm going to use numpy.random. And you can see there's all these different random samplings, just random.random in this case. If you look at the doc string, you see that we're going to get random floats in the half open interval from 0, including 0, to and not including 1. In this case, I want that length of 100. And then I'm going to go ahead and save myself a little bit of typing and create y2 and y3 as well. Of course, if you're doing this programmatically, including creating these multiple subplots that we're going to do, you can and should make that a little bit more automated. But in this case, we're trying to talk about how the subplots are laid out, so we're going to copy and paste a little bit here and there. Next, I'm going to make a figure. So plt.figure. I'm going to specify my fig size as 10 by 8. So first, ax is plot.subplot, and we've seen this a lot in previous MetPy Mondays, is 1, 1, 1. That is one row, one column, and this is the first panel that I want to plot on. That'll become clear in a little bit when we do more than one row and one column. Then our standard ax.plot. In this case, I'm going to save myself typing 3 plot commands. You can actually chain, so x, y1, x, y2, x, y3. These could even be different x's if I wanted. When I run that cell, we see I get this plot with our 3 default colors in the colored cycler here. And we see random scatter between 0 and 1, just as we expect. The problem is that because all of these data are in the exact same range, 0 to 1, it's impossible to tell what's going on here. They're all overlapping. And for example, if I were looking at some details in here without zooming way in, it's not clear at all. And even zooming in, they're still overlapping and it's hard to tell what's going on. So what would be a little bit easier to do is create another figure. So we're going to stick with the same figure size here. When you're creating these multi-panel plots, a lot of times you have to play with figure size to get it to turn out how you're going to want it for publication. That's just a game of changing the X or Y dimensions a little bit, and until you get the aspect ratio that you want, though starting with something like the golden ratio is always a good rule. So now I'm going to create ax1. So notice instead of just ax, I'm calling this ax1, plot.subplot. And now I'm going to say 3, 1, 1. So this says that I want 3 rows of subplots, 1 column, so 3 subplots total. And then the last one means that I want axis 1 to be assigned to the first one of those subplots, in this case, the first row, first column. ax2, plot.subplot, 3, 1, 2. So I still have 3 rows, 1 column, but now I want to be working with the second row. And then ax3 is plot.subplot 3, 1, 3. Now I'm going to actually have to have 3 separate plot calls because I'm plotting on 3 different axes objects. So ax1.plot, xy1, ax2.plot, and this is where I was saying you could automate this up some. If you were doing this programmatically, you could generate in plots and have some logic in here to help you with that, much as we did in the radar multi-panel animation at the end of the radar series a few weeks ago. xy2 and xy3. So now what we get are 3 separate panels. So 1 column, 3 rows. The data are plotted individually on each one, and since each panel only has 1 series plotted on it, they're all the first color in the color cycler, that nice blue color. So that's relatively straightforward. But what if I wanted to have, say, 3 rows and 3 columns for a total of 9 panels here? Well, all we have to do is change the second number from 1 to 3. So now we have 3 rows and 3 columns for 9 total plots. If we stay with exactly what we have now and run it again, you'll see we just get 3 subplots across the top. Panels 1, 2, and 3. So the numbering is going to go 1, 2, 3, then 4 will be the second row, first column, 5, 6, 7 will be the third row, first column, 8, 9. So if I want to plot along the diagonal here, I'm going to use subplots 1, 5, and 9. And now when I run that, we see the total plot area here. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. I hope that you found this useful and can start utilizing subplots as a way to prevent yourself from having to create multiple figures and then combine the panels together in something like Illustrator, where it's difficult to revise because once you change one part of the figure, you have to open up Illustrator again and reposition annotations and get things exactly how you want them again. Using this is a much more versatile way and a way to generate massive amounts of images programmatically. If you found this video useful, please don't forget to click like and subscribe down below. You can find us on Twitter, we're at MetPy and at Unidata, and on Facebook, just search for Unidata. I'll see you on next week's MetPy Monday.